Right. So this is class, what's this, class 9? 4A. You know, one of the biggest issues that I noticed in the exam is that students do not read the question first. They just start answering it. I don't know how you want to start, how you start answering without reading the question. That's because remember the last question in the exam, question 3 was about F-test, right? So it was stated in there that you have to carry out an F-test of joint significance, right? It says explicitly F-test of joint significance of sort of two coefficient estimates. Now, many students, not only some, many students, maybe half, straight away, went to doing t-test by transforming the regression into a different one so that they could do t-test on two coefficient estimates. I don't know why they did this. It's correct to do this, and the full answer was correct, but in terms of the question asking F-test, it was incorrect, so you get 0 mark for that. Although the procedure is correct, the question was about F-test, not t-test. It was about your knowledge of F-test. So you get 0 mark for that. And some students, very good, had very good marks for other questions, and they had lost 12 marks, entire 12 marks, for example. Yeah, and then they are asking why mine is low mark, and because probably that you just didn't read the question properly, and you just went on doing t-test instead of F-test. So again, whenever you do the thing in the final, try to understand the question first, what it is asking. If it asks X, why are you doing Y, sort of thing. Yeah? Don't attempt something extra other than what is required from you. So let U be a random variable with expected value equal 0, variance equal, thank you, sigma square. And keep this in mind, the covariance of UT and US is 0. Now this is US, and we say T is not equal to S. So what's this last condition implying? What is the implication of the last condition? This we have condition 1, 2, 3, and we are given A. YIT, is it IT? No, it's a time series, so we don't need that. I equals 2 plus uh, 1 over 2. This is 1, sorry. So any input on any thoughts on what the condition, third condition imply? Anyone? So the T not equal S implies basically T minus P is not equal to T, right? So some lag P. So there is no serial correlation, right? Errors are not correlated over time. There is no serial correlation. So this UT is basically white noise. So something like this. If this is a 0 line, this is the error term. In this exercise, it's not an important point, but in the future, in the final, you have to be careful with these conditions. Next, question here is about something else. Which of the following models have a unit root? So I'll do A and you do the rest. You get the solution later, but you try to do it before the solution is given to you. What was the procedure for establishing whether the some sort of equation here is a unit root process, has a unit root process, or some sort of series. How is this an AR process? Is this an AR process? Yes, no, guys? Yes? What's the lag order? It's AR2 process, right? And for any ARP process, to check if that process has a unit root, what you do is you solve this polynomial equation. You see, power is the same as the subscript for beta. Now in our case, we have only two lags for this equation. So what we do is we just transform this now. 1 minus beta 1 is on the first lagged term, so that's 3 over 2 z minus beta 2 is 1 over 2 times z squared, because this is second lag, and equal to 0. Solve this equation now. So we just, let's do transformations here. What we get is simplified is this then. This is 3z plus 2 equals 0. It's the same thing, right? I just dropped 2 by giving a common term denominator, and this would be 2 here, and this 2 drops out.
Where'd you get to?
And then these 2's go away.
You got 2 in your original.
Yeah, 1 over 2, 3 over 2. This is 1.5, this is 0.5.
And 2 is from B1 after that.
This one.
I know. B1 minus B1 0.
1 minus
Yes.
3 over 2. Yeah, this is 1.5 in the equation.
In the original, it's 2 plus 3 over 2.
Yeah, that's because I'm replacing this bit. I'm looking at this equation now. Remember we said to establish whether this process is a unit root, you solve this equation. So the beta 1 here is 3 over 2, so this is minus 3 over 2z. Minus, then minus beta 2 is minus 1 over 2 z squared, and equals 0. So solve this equation now. And if you solve, you get z1 equal to 1, z2 equal to 2. And if any of the roots is equal to 1, then this process is unit root process, or this AR process has a unit root. This model has a unit root basically, because at least one of the roots of this equation is equal to 1. In the next equation, you have no roots equal to 1. That's a stationary process. B. Third equation is also stationary. No, it is also. Let me have a look. Yeah, it's also stationary. Last equation has a unit root, but then you have to solve it yourselves now. We jump to class 10 now from now on. This is something that we did last week as well, and you do this one, attempt this question on your own before you get the solutions, please. It's practice for you. Maybe in the final you see some sort of question like this. So class 10 now, guys. So AR2 has a unit root. This model has a unit root basically because of the root of the polynomial equation equal to 1. Erase, clear, pen. So class 10.
How do you know if it has a unit or not?
By looking at the roots of the equation.
Got 0 and 1.
If one of the roots is equal to 1, the AR equation, the original model, has a unit root. If not, then it's a stationary process. So let's rewrite this model. And the question says, transform the regression so that beta j, the beta coefficients beta 1 and 2, can be estimated. I is the entity dimension, individuals dimension, and T is the time dimension. It's a panel data model. Now, I want to ask you this question. Why do I need to transform this regression? Isn't it just easy to run this regression? What's wrong with this? What's wrong with this regression, if there is anything wrong with it?
You go I's and T's.
Okay, what's
T's the time, huh?
yeah? I is for entities, right? So
different entities. It's a panel data.
so you get panel data. Let's say if you have United States data. Let's say world data. You have 200 countries, and your x's are education variables, and y is, let's say, growth, GDP growth, and you want to check what effects or what the effects beta 1 and beta 2 are on GDP growth. So x's are being education variables, and then you have 10 years of data for each country. So you have 200 countries with 10 years data means 2,000 observations, right? So what's wrong with it then? This data is sufficiently long. When you run such regressions, you have 200 entities in 200 countries, and it's a GDP growth equation, growth equation, let's say. Growth is not necessarily affected by a single factor. It could be affected by so many factors, right? Unobservable, observable. And especially with education. In some countries, for example, X here, the education variable, could be determined by culture. In some countries, you have kids going to school, halfway through, dropping out, helping the family, yeah, supporting families, for example. And this is a norm, a normal occurrence. So this is attitude towards the education of children. And some countries, it's a must thing to go to A level and then do whatever you want, for example. So is education, attitude towards education is different across countries, isn't it? An attitude, for example, or norms are not observable. You cannot observe them. For example, this alpha I doesn't have T dimension. Notice this. It doesn't change over time, but it's changing across countries, yeah? The I goes up to 200, for example, in this case. Each country has its own sort of culture and unique cultures that determine their growth, for example, paths. Now, how would you account for them in this regression? This is the problem here. We don't know what alpha, what to do with it. What we can do is, last week we said it could be dummy variable method that could help us. We could actually include dummy variables, dummies or binary variables for each country to account for these unobservable factors. Now, assuming there are 200 countries, you have 199 dummy variables there, because one needs to be dropped out, yeah? One needs to be dropped. So you have 99 variables plus 2 x's. Then you have 201 dependent variables, isn't it? in many cases. So this would be a large, inclusion of large variables into this equation. Rather, we could think of removing it. For example, if we do not include, for example, anything to account for fixed effects, for example, the cultural effects that I talked about. I'm taking it longer because this is important that you understand this. If it didn't include anything, no fixed effects, this becomes our new error term, EIT, which means alpha I is included EIT, and EIT is now correlated with either of the x's, possibly, and it means beta 2 and beta 1s are not unbiased. They are biased now because it's a classic case of biased estimator, and it will also be inconsistent estimator. So we need to get rid of alpha I or account for it through dummy variable method. Now researchers said, econometricians I should say, said, why don't we demean each variable and then see if we can get rid of alpha I? That's a good idea. So demeaning. So first of all, calculate it's a transformation of data only, purely transformation of data, nothing other than that. The mean each variable over the time period. Take the mean of time variables over time mean. So this is x now. So these are means of each variable. Now rewrite the equation in mean as the with the averages, resulting averages.
Is your sample is your estimated one?
This one's sample data, yeah. These are samples, just taking the time mean. So if you have 10 years in each year, in each country, for each country, then it's the average of the values over 10-year period. So this would result in this sort of setting, yeah. And let's call this equation 1 and this equation 2. So the first equation is the original equation and second equation is the mean equation here, equation with mean values. So you have 200 countries, so I goes to 200 observations here. Then subtract the second from the first equation. What you get is then, actually this is I. And let's call this a new variable. You see what I did here is just transformation of data, nothing. I haven't even estimated anything. And call this x1it just with tilde. So this differencing here is just x1it. Plus, now notice that alpha i's disappear now because they cancel out. Then you have this left. Now in the transformed regression now, you don't have alpha I. You don't have alpha I. And you don't have to worry about fixed effects now. So it was easier than what it looked like before, right? Now in the next equation, you have time dimension. This is time fixed effect. So in some countries, things change over time. And in each country, I think, the factors that are unobservable but change over time. In the short term, I should say, not in the long term. 10 years data is not that long. Now, I leave it to you to do the B. But do it before the solutions are revealed to you. Just follow the same exercise that we've just done, procedure, and take the average over entities now. So for each time dimension, you will have now average over entity. For example, well, you do it. I leave it. I leave it to you, guys. Sorry, it's not a good idea to just to show you everything. You need to get something to do done by yourselves as well to learn. Now, question 2 is descriptive. It requires interpretation of given regression results I will leave it to you as well. You get a half a page long explanation. This is the longest explanation to a question usually. Solution is quite long, and it's a quite comprehensive one. So we've done it many times. What I will do now is, instead of going into question 2, I'll do question 3, which is a short answer provided. Plus, we'll discuss inconsistency of estimator, which would be most likely in your final exam, assumptions of OLS and IV. So let's do question 3 instead of 2. 2 is a discussion question, so you will do that at home, or if you cannot do it, you will have the solution, and quite comprehensive solution compared to the third one. Question 3, class 9. Consider a product market with a supply function which has the demand equation and in equilibrium we expect the demand to be equal to supply, and also another thing we're given is that covariance between the error terms is 0. So they are IID, mutually independent. Now notice that demand equation doesn't have a price variable. It's not a function of price, implying demand is inelastic with respect to price. So it's a very, very essential good, yeah? Even if it's £1 million, you have to buy it, basically. But supply is elastic with respect to price. And well, we don't know exactly how much it is. So it's a function of price, we can say that. Okay, A. Keep in mind these conditions are important. Show that price and supply error are correlated. Now, question is, what happens if price and error is correlated? Well, it looks like 5, it's S. Guys, what happens if price and error is correlated? Nope. What happens to beta 1?
It's omitted variable.
Yes, there is omitted variable in UI included in there. So if they correlate, there's an omitted variable bias on beta 1. And we have to show that they are correlated and there is an omitted variable bias possible, and inconsistency as well in the estimator. But let's show that then. Using the equilibrium condition that demand is equal to supply, we can then solve this equation for price. And solve for price, subtract beta 0 on both sides and UIS as well. You should get, put the variables and constants separately. So bundle them together. And this beta 1 could be, if you divide both sides of equation by beta 1, you get beta 1 here, you get beta 1 here, this will disappear. So this is the result here. P is basically equal to, and we know that now the price is a function of supply error, yeah? Error in the supply equation. But we haven't yet showed that they are correlated. To do that, you will just to take the covariance of price and UIS. And we know the equation for price, so you just plug that into this equation, covariance operator. So we have to now expand this bracket, covariance operator. Now this whole thing, whole expression is constant, yeah? So correlation between constant and UIS is 0, so you can drop this. What we'll have is then beta 1 over beta 1 from here. This denominator is a constant here. 1 over beta 1. Covariance between UID minus UIS equals, sorry, it's not equals. It's basic covariance between this expression and UIS. This gives us this expression now. Now the question, what is this equal to? 0? Why 0? Yeah, it's a condition, isn't it, that they are uncorrelated. So if you ignored it in the beginning, you wouldn't figure out what it is. So make sure you look at this carefully. So we'll have now 1 over beta 1 because this is variance of US, yeah? Covariance between US and US is basically variance of US. Now, what did we just show? We just showed that this is not 0. Covariance between PI and UI is some constant with a negative value. And that's question A done. Now we have to show that the Euler's estimate of beta 1 is inconsistent. B. Maybe it's sufficient to start here. Now, the estimator, OLS estimator, beta 1 hat OLS is equal to beta 1 plus some rho P and U in this case. It's the correlation between P and U, sigma U. So this is the standard deviation of U, and this is the standard deviation of P. Now use the fact in A, the finding in A, to prove that this is inconsistent estimator. OLS is inconsistent estimator. Now what is this rho equal to? Guys, what's the formula for correlation between P and U? Covariance, PU, variance, P. Exactly. What's known to us is this part here. We know what this is, yeah? Yes, no? Yeah. You know it, yeah? It's minus 1 over beta 1. It's this thingy, basically, that we calculated before. Actually, my beta is being funny here. Let's rewrite it. So this is basically the case. This is equal to this constant value. If beta 1 is not 0, sigma U is not 0, obviously. So this is constant. Constant divided by the variance of P and U is a constant. So this thing will be some constant value times this gives us a constant here. As a result, the true value, in fact, this is in probability. This is not exactly equal. It approaches in probability to true value beta 1. So the OLS estimator of beta 1 approaches in probability to true beta 1. But because of having the correlation between P and U, the beta 1 hat is not exactly, or is not approaching to beta 1. It's actually approaching to some other value with bias. This is the bias, amount of bias on beta 1. Is this clear now where the bias comes from? It comes from basically from the correlation between the a variable and the error term. If you have this bias or this sort of correlation in the equation, then estimator is also not is not consistent. It's not consistent. What we mean by consistent estimator? What's the property of a consistent estimator by definition? So you take a sample, you estimate beta 1 hat, and then you take larger sample, you estimate beta 1 hat again. As you increase the sample, beta 1 hat approaches the true value. But in this case, it is not the case, basically. It's not that case. Because no matter how large sample you take, if P and U correlates, you still get the bias. So actual true value, you cannot approximate the actual true value using OLS. So you have to use some other estimator then. Is this clear, guys, where the bias comes from here? So it is inconsistent in the sense that no matter how large sample you choose and run regression, this bias persists because you have a covariance or correlation between this P and U. And this is causing that inconsistency. So it's, if, for example, this is the sampling distribution of beta 1 hat, we expect the expected value of basically beta 1 hat to be equal to, for example, beta 1 right here. But you take sample and estimate, ignoring the correlation between P and U, you get beta 1s that are falling around somewhere there, somewhere here, not exactly here, or not approaching, this point. It's actually randomly going around, right? So it's an inconsistent estimator, for example. Simple explanation, but not the exact explanation to this inconsistency. So we just showed this now, that because covariance between P and U is not constant, is not zero, sorry, it's not zero, right? It's not zero, it's some value here, it's this value here, right? As a result, we have correlation, and this correlation is also probably negative correlation here, so the bias is downward, as we get a smaller beta hat than the actual beta because of the negative value. Okay, we don't have to go further. I think that explanation is sufficient. Go to C now. How are we going to estimate this now? This is interesting. So think about C for a moment. Let me clean this now. Guys, think about C. C says, how would you estimate the coefficients then? Beta 0, beta 1, and gamma 0. Usually we do an instrumental variable method. We use that method to estimate the coefficients. Do you know how it works? How instrumental variable method works in a nutshell? Sorry, what? No, you don't. Did you not attend the lecture? You skipped the lecture. Has anyone attended the lecture? Is anyone attending the lectures at all? No? No one? You? No?
There are so many people in the lectures.
You're joking. So you don't know then what IV estimator is? Right, nice. Okay, IV estimator. Basically, think about this now. I'll just quickly give you an example here. Assume you have yi equal to beta 0 plus beta 1 xi plus ui. And assume that ui is correlated with xi. As a result, beta 1 will be, confused, estimator will confuse, and will actually absorb things that it shouldn't absorb. So it will be some biased estimator. Now, instrumental variable estimator says, find some third variable a variable we call z, let's say. Find z. And this has to be exogenous. Guys, this z has to be exogenous. In other words, covariance between zi and ui is 0. That's the exogeneity assumption. What do you mean by exogenous? It's given, predetermined, and is also not determined in this equation. It's not part of this equation.
So you need to take something from outside.
Take something from outside if you can.
Like what?
Like anything that you think of that is not correlating with u. Anything in the u is actually everything, right? In this equation you have y, and you have only one variable, and everything else in the world is absorbed in u. So you need to find the variable that is not correlated with everything, but only xi, x. This is very difficult undertaking.
When do you use this method?
When xi is correlated with ui, to avoid bias and inconsistency. Now, it has to be relevant instrument. In other words, zi should be correlated with xi. So this, if you meet these assumptions, you can use zi to instrument xi. Now, guys, if you find some zi that correlates with xi but not ui, then you are a good researcher. Depends on the problem. I'll tell you my personal experience. I spent 1 year, 12 months, exactly 12 months I think, but maybe a bit more, trying to find an instrumental variable for energy consumption, and wasted whole year without success. So I had to abandon that project after 1 year. So you have 4 years for PhD. Imagine I have only got 3 years now to do the rest. So that's the sort of thing. Yeah, good luck with IVs. It's, if you're creative, you could be able to construct the z's yourselves and make a case that it's not correlated with everything else. That's not in the regression, but only xi. This is the hardest part. Now what you do is here, it's a two-stage basically. This is the second stage usually. In the first stage, you take, in this case it's xi, and regress it on some constant and zi, and extract the fitted values. In other words, get the fitted xi's. In other words, get the hats. Ignore the ui now. And then, when you run this regression, you have x here and z here, right? You have all these observations, assuming there's a positive relationship between them. You fit this x hat I, right? The fitted values are on this line. So take this and plug this into this x, and then you run the regression, you get unbiased and consistent beta 1. That's the gist of instrumental in practice, instrumental variable method. Is this clear? And that's exactly the same thing in your lecture notes. If you didn't attend, just read it and you will see this is the case. Yes? Now, going back to the case we are dealing with, we need to find instrument for pi. What instrument can we use? Can we use demand equation? Demand, the quantities demanded? Because notice that supply is independent of demand here.
How do you know?
This price is not in the equation. You see, you don't have the price here. So essentially, if these two are unrelated according to this, and this is just a constant there, you can estimate it. P could be instrumented with Q.
So what can be like your Z in this case? What can we use
Z is Q basically, in this case.
quantity.
Yeah.
But it's, I think
It's supplied here. This is quantity supplied, this is quantity demanded. Two different things, yeah? Yeah?
So this is the answer to your question. What's the energy consumption?
Yeah, I didn't find it. I mean, it's hard to find that because mine is a demand equation. There's demand for energy, and I need to find something exogenous that makes some countries consume more energy than others.
Supply of energy.
No, it didn't work because supply of energy depends on a lot of things, and the U is correlated with supply of energy. If I do that, so I tried to find something out of this things like some people used weather conditions which are exogenous to economies of it's independent of economic decisions, right? It's exogenous, but then weather conditions affect not only energy consumption but a lot of things in the error term that I didn't include. So it was a lot of thinking and a lot of tinkering and useless, time wasted. But it actually you learn by mistakes. So it was something that I will never repeat now, hopefully. Right. So number 4. Now this is explanation to what we just did. We will derive the IV estimator. So let's consider this equation which says yi is dependent on some xi plus some wi plus ui, and we are given zi. It's already determined that what zi is. We know what it is. It's just an instrumental variable. And also we are given information that wi is not available. Data on wi is not available. Implies we will not be able to include the wi in the regression, meaning this would be in the error then. Yeah, it will be in the error. If you do not include the data that correlates with xi or yi, it should be in the ui then, isn't it? Yeah, it should be part of error. Now, given that if xi and wi correlate, then you have the bias on beta 1. But let's go on what it says. Suppose that I and wi are uncorrelated. Is the IV estimator consistent? Now we'll have to find out by looking at what IV estimator is. It is basically this formula. I should really say it approaches in probability as you increase the sample size. It's between covariance between Zi and Wi over, sorry, this is Yi, I'm sorry. It shouldn't be Wi here. Wi never comes into this equation. So this is Yi over covariance between Zi and Xi. Now what we have is this equation for yi, so why don't we plug that in? So covariance is Zi beta 0 plus beta 1 xi plus beta 2 wi plus ui, this is ui, over covariance xi and zi. Now expand this thing, covariance between Zi and beta 0 over covariance between xi Zi plus 1 beta 1 covariance between Zi and xi over covariance between xi and zi plus beta 2 covariance between zi and wi over covariance between xi and zi. It's a long simplification, shouldn't have gone this way, but just to make it clear. Now, question: what is this equation equal to? Expression?
0.
Why?
Independent.
What do you mean independent?
Z and 0 must be independent.
Z and
So if you
this is constant, isn't it? Beta 0 is constant, so they don't co-vary, so 0. How about this?
beta 1,
Z and X?
0.
Z and X? Cancel. Not 0, yeah? It's a covariance between Z and X, Z, X. This? Will stay because we don't know the correlation between them. How about this? Zi and ui. What's the same? It will stay the same, you mean?
What's error term? So it's
Ui is error term. And zeta is instrument.
because you take the variable outside, must be back to these options. It must be
So Zi is an instrument and it will be 0, yeah? Correlation will be 0 between them because Ui is error and instrument is supposed to be
not correct.
not correct, so 0. Now you will have this equation now, expression to work with. We can now read the question and see what happens here, what the thing is about. So basically this is beta 1 hat IV estimator. And it will approach in probability to this condition, to this value. As we can see, if covariance between Z and W is not 0, this estimator is inconsistent. No matter how large the sample is, the estimator will still get this amount of bias on this. As a result, in large samples, beta 1 hat IV will not be approximate to beta 1, or will not be approximating actual beta 1. This is a true beta 1, yeah? Plus some bias. However, in B it says, what if they are not, in A says, what if they are not correlated? In other words, zeta and Wi are not correlated. Then this whole thing will be 0. Then you have this thing holding. So it's a consistent estimator. Okay, 5, 6 is a homework for you. And you get the solution on Moodle. Sorry, QM+.